Let's jump right in. When you hear the words artificial intelligence, what actually comes to mind? For a lot of us, it kind of feels like magic, right? Or maybe pure science fiction. But as we're going to see today, AI isn't magic at all. It's actually the fascinating, super methodical process of trying to put the human mind into computers. Welcome to this explainer. I am absolutely thrilled to guide you through this because once you see the actual blueprint behind AI, it completely changes how you look at the technology all around us.
We've got a lot of ground to cover, so here is our roadmap. 1. What is AI? 2. The history of AI. 3. Mirroring capabilities. 4. How machines learn. 5. AI versus data science. And finally, 6. The physical world. Let's get to it.
Section 1. What is artificial intelligence? Putting the human mind into computers. At its absolute core, AI is fundamentally different from regular traditional programming. Instead of just following a strict list of pre-written rules, AI actually trains for a task so it can figure out totally unfamiliar situations completely on its own. Now, you might be wondering, why is AI suddenly everywhere right now? Well, it comes down to 4 pillars forming a perfect storm. Basically, we're experiencing a massive flood of available data, mostly thanks to the internet. Combine that with skyrocketing computational power, huge leaps in algorithms developed by researchers, and massive financial support from big industry. Those 4 pillars coming together, that's what made AI a reality today. But here's a kind of surprising fact. While AI feels incredibly new, the concept is actually over 70 years old. Let's look at Section 2, the history of AI, from concept to reality. The whole journey started way back in 1943 with the very first model of artificial neurons. By 1950, Alan Turing was already writing about how we could even test machine intelligence. The actual term artificial intelligence wasn't coined until the Dartmouth Conference in 1956. We even had our first chatbot, named Eliza, way back in 1966. But, it wasn't a smooth ride. By 1974, the field hit a brutal wall, known as the first AI winter. This was a really tough, frustrating period. Government funding completely dried up, progress crashed to a halt, and public interest just plummeted. Obviously, that winter didn't last forever, right? The field spectacularly bounced back. In 1997, IBM's Deep Blue made massive headlines by beating world chess champion Garry Kasparov. And then in 2002, this incredible, world-beating technology finally arrived in our homes to vacuum our carpets. Enter the Roomba. But the leaps just kept coming. We saw machines mastering really complex human language, like IBM's Watson winning the quiz show Jeopardy in 2011, and project debaters successfully arguing incredibly complex topics against master human debaters in 2018. So, how exactly did we go from vacuuming floors to debating complex philosophy? That brings us to Section 3, mirroring human capabilities, the blueprint. How do we actually translate what we do naturally into lines of code? One of the absolute best ways to wrap your head around the different sub-areas of AI is to just look at our own human senses. Think about it. If a human uses their eyes to see, AI uses a field called computer vision. Human hearing maps directly to sound processing. Our ability to understand and speak language becomes natural language processing, and human reasoning translates to automated reasoning. It's pretty cool. Every major field of AI research is really just an attempt to digitize a specific human capability.
Let's actually look a little closer at that last one, reasoning. Humans reason in a bunch of different ways, and so machines have to as well. The first type is deductive reasoning. This is where a machine uses established facts and general principles to predict a specific, valid conclusion. For instance, if the general fact is that people aged 20 and above actively use the internet, the AI can deduce behaviors about specific individuals who happen to fall into that age group. It moves from a broad, general rule down to a detailed fact. Contrast that with inductive reasoning. This works in the exact opposite direction. You start with specific, detailed facts, and you build up to a broad, general principle. Here's a great example. If an AI observes that every single pigeon it has ever seen in a zoo is white, it uses inductive reasoning to form a general hypothesis. We can expect all pigeons everywhere to be white. And finally, we have abductive reasoning. Now, this one is fascinating because it specifically deals with uncertainty. It begins with an incomplete set of facts and tries to find the most likely or deserving explanation. Think of a doctor making a diagnosis based on just a few test reports.
The AI makes the absolute best possible guess based on the limited evidence it has. It's a lot like what you do when you see wet roads and assume, hey, it probably rained, I should grab an umbrella.
But here's the thing, reasoning alone just isn't enough. A truly intelligent agent doesn't just sit there and think, it acts. Which leads us to a really thought-provoking question. How does a machine actually plan out a sequence of actions to achieve a specific goal? To understand planning in AI, let's look at a classic logic exercise, the monkey and bananas problem. Imagine a monkey in a lab. There are bananas hanging from the ceiling, totally out of reach. There's also a box in the room. In this scenario, the AI has to act like the monkey. It knows its starting state, it knows the actions available to it, like walk, push, climb, and grasp, and it knows its final goal. The AI has to plan a procedural course of action. Go to the box, push the box under the bananas, climb onto the box, and grasp the bananas. Planning is simply the AI figuring out and choosing the sequence of actions that has the highest likelihood of completing the task. Still, reasoning and planning alone aren't the whole picture. Section 4. How do machines learn? The evolution. Let's look at how computers automatically improve through experience.
A brilliant way to understand this is through reinforcement learning. Honestly, it is incredibly similar to training a dog. In this analogy, the dog is our AI agent. First, there's an observation. The trainer gives a cue, like saying sit. Second is the action. The dog responds, maybe totally randomly at first by rolling over. Third is the reward. If the action is right, the dog gets a treat. If not, no reward. And finally, policy tuning. Over time, the dog associates that specific cue with the correct action to maximize the reward. Machines learn the exact same way. They use trial, error, and reward signals to constantly tune their internal policies.
Now, as these machines learn, they naturally process a massive amount of information. Which brings us to Section 5, AI versus data science, drawing the line. These are massive industry buzzwords that get tossed around and confused all the time, but they are absolutely distinct fields.
The stark contrast between the two really lies in their end goals. Data science is all about extracting value and curating massive amounts of data for analytics. For example, an airline using data science looks at historical booking data to predict patterns and optimize their future ticket prices. AI, on the other hand, is about imposing intelligence so a machine can act human. While data science looks for patterns to make well-informed decisions, AI uses loops for active planning and perception. Simply put, data science tells you what the data means. AI uses the data to behave intelligently. For our final section, let's look at what happens when AI actually leaves the computer screen and enters reality. Section 6. AI in the physical world. Perception and motion. To interact with our physical world, an AI first needs perception. This is the vital process of taking raw inputs from sensors, like cameras, microphones, or sonar, and actually interpreting them. Look, sensation is simply getting a raw signal. Perception, however, is putting that data together to actually make sense of the environment around it. That could mean recognizing a spoken command or identifying a pedestrian suddenly stepping into the street. And this perception is completely revolutionizing physical industries, like mechanical engineering and manufacturing. AI isn't just trapped in your phone anymore. It's generative design software that creates highly optimized product blueprints based on weight and cost constraints. It's the industrial Internet of Things, constantly monitoring factory equipment for predictive maintenance and ensuring workplace safety. It's autonomous vehicles zooming around the production floor and robotic arms performing complex repetitive tasks like welding and painting. And why does this matter to you? Because this physical application of AI is what's making the cars you drive safer, the products you buy cheaper, and the massive supply chains keeping your grocery store stocked infinitely more efficient. When you finally combine that perception with motion and manipulation, you get marvels like ACMO. Created by Honda, this humanoid robot stands 130 centimeters tall and weighs 54 kilograms. It doesn't just sit there processing data. It physically moves around, displaces objects, and navigates our very real world. This is where high-level intelligence is required to physically handle complex tasks in real space. All of this brings us right back to our starting point. As researchers look to the future, there's a powerful realization driving the industry. Understanding of how the human brain works will help us create better AI. The fields of computer science, biology, and psychology are now deeply, permanently intertwined in this pursuit. We've seen how machines can reason, plan, perceive, and even learn from rewards exactly like we do. They're mirroring our human capabilities, step by step. Which leaves us with a pretty profound question to think about. As artificial intelligence increasingly masters our senses and our logic, what truly remains uniquely human? Thank you so much for joining me on this explainer. I really hope this structured look at AI has sparked your curiosity to go out and learn even more.